Hello friends, today you are all welcome to the Government Ghosh channel. Kindly subscribe the Government Ghosh channel. Today we discuss the question number 18 of chapter 5, exercise 5.1. The chapter name is the continuity and differentiability. The question number 18 has come many times in the CBGC examination, and be clear about these questions. The question is, for what value of lambda is the function defined by f of x equal to lambda into x square minus 2x if x is less than equal to 0, 4x plus 1 if x is greater than 0, continuous at x equal to 0. The second bit of the question is, what about the continuity at x equal to 1? So first we discuss the continuity at x equal to 0, and here the function is given continuous. Then you find the for what value of lambda the function is continuous. Then second bit will be this one. First we discuss the first bit. Here the function is given in two sections. In first section, x is less than equal to 0. In less than equal to 0, it is defined by lambda into x square minus 2x. When x is greater than 0, in that case it is defined as 4x plus 1. Here given, or here we have to find the value of lambda when the function is continuous at x equal to 0. When x equal to 0, we have to find the value of lambda. As the function f of x is continuous at x equal to 0, we assume that it is given. If the function is continuous, the definition of continuity is left hand limit equal to right hand limit equal to function value at the point. So here the point is x equal to 0. At that point we have to show left hand limit equal to right hand limit equal to function value. Then we have to find the lambda value. We discuss here the left hand limit. Then as per the definition of left hand limit x tends to 0 minus f of x equal to limit x tends to 0 minus h f of x. This equal to limit h tends to 0 f of 0 minus h. So here this is left hand limit, it is less of h, very small less of 0. So that amount is h. H is a very small positive number. So we written this 0 as 0 minus, or that is 0 minus h. And as per the definition or as per the limit, this is limit h tends to 0 f of 0 minus h. F of 0 minus h is your f of minus h. F of minus h, limit h tends to 0, f of minus h means h is a very small positive number, then minus h will be less than equal to 0. So it is defined by the first function of the given function. This is negative, so it is defined by the first function of the limit. So it is defined by the x less than 0 because minus h is less than equal to 0. So you substitute the value of x as a minus h here and here. Then you will get that will be lambda minus h square minus 2 minus h. So that will be minus h square will be h square minus 2 into minus h equal to 2h. Now there is no step to simplify more. So you substitute the value of h as a 0. So lambda h square plus 2 into h, that will be 0. So lambda into 0 equal to 0. So left hand limit equal to 0. Here we have to find the right hand limit. The formula of right hand limit at x tends to 0 is limit x tends to 0 plus f of x, or that will be 0 plus means 0 plus h. H is a very small positive number. The limit x tends to 0 plus h f of x, and this equal to limit h tends to 0 f of 0 plus h. Then 0 plus h here f of h. h is a very positive, small positive number that is greater than 0. So you go to the second condition of the function, that is 4x plus 1. That is 4x plus 1. So this is the function is f of x equal to 4x plus 1. Then f of h is 4x plus 1. So in this place you substitute 4h plus 1. So in place of x you substitute this h. Now there is no need to, there is no steps to simplify more. So you substitute the value of h as a 0 here. So that what happened? 4 into 0 plus 1, or that is 0 plus 1, that equal to 1. So right hand limit is here 1. Now we have to find the function value. The function value is f of v, the function value, that equal to at x equal to 0. So f of 0. F of 0 is defined as the first function lambda into x square minus 2x. So x is 0. So lambda into 0 square minus 2, 0. So this value again lambda into 0 minus 0. You see here. So that lambda into 0 equal to 0. So here what you got? The left hand limit is here 0. The left hand limit is 0. Right hand limit is 0, 1. And function value is 0. You see here you got the function value 0. So these three are not equal. So 1 will never be 0. So this is one of the impossible situation. So there is no such lambda for which the value f of x will be continuous at x equal to 0. So this is very simple thing. Next we discuss the second bit of the question, that is what about continuity at x equal to 1. So we have to discuss what about the continuity at x. So at x equal to 1, the function is continuous or not. Then again we will go to the same situation, that is we have to find the left hand limit, we have to find the right hand limit, we have to find the function value. If these three values are equal, then it is continuous. So at 1 we have to test. As per the definition of the left hand limit, the limit f of x extends to 1 minus. 1 minus means 1 minus h. So limit extends to 1 minus h. So this can be written as, that is x is replaced by 1 minus h and h is a very small positive number. So limit h tends to 0 f of 1 minus h. So this is the definition of left hand limit. Then f of 1 minus h. 1 minus h. So the function is given in two conditions, that is x is less than equal to 0. Another condition is x is greater than 0. Another is x greater than 0. Then what happened? X greater than 0. Here 1 minus h. H is a very small positive number. So you assume h equal to say 0.001. Just you assume h equal to 0.001. Then what happened? 1 minus 0.001 equal to 0.999. So this is taken as a 1 minus h. So f of 1 minus h is f of 0.99 approximately. Then what happened? That will comes under the condition x is greater than 0. In x equal to greater than 0, the function is given here f of x equal to 4x equal to 4x plus 1. 4x plus 1. This is given the function. So what happened? This is 4x. X here 1 minus h. X here 1 minus h. So 4 into x, 4 into 1 minus h plus 1. So limit h tends to 0, h value, put the h value is 0. So that is 4 into 1 minus 0 plus 1, that is 4 plus 1. So this equal to 5. So left hand limit equal to 5. Again we have to find the right hand limit. So right hand limit is limit f of x extends to 1 plus, just right side of the 1, that is 1 plus h, very small increase of 1. So that small amount is taken as a h. So that x tends to 1 plus h. So limit extends to 1 plus h f of x. Then this x is replaced by this and h will be tends to 0. So limit h tends to 0 f of 1 plus h. So this is the right hand limit. Then what happened? Then you substitute the value of f of 1 plus h. Again f of 1 plus h will become under the x is greater than 0. In that case, the function f of x is given here 4x plus 1. 4x plus 1. That is given here 4x plus 1. 4x plus 1. So this is limit h tends to 0, 4 into 1 plus h plus 1. So this is. Then put the value of h is 0. So 4 into 1 plus 0 plus 1, that is 5. So at the end we have to put the value of h equal to 0. Not at the beginning. So after all simplification, we substitute at the end h equal to 0. If there is no step for the further simplification. So that will be right hand limit equal to 5. The functional value. The functional value is f of 1. F of 1 is again defined in the condition x is greater than 0 condition. That is 4x plus 1. So that is 4 into 1 plus 1, that equal to 5. So in all, that is f of x, the function value f of v will be here 5. So left hand limit is here 5, right hand limit also 5, function value also 5 at x equal to 1. So all these three are equal at x equal to 1. Therefore, the function f of x is continuous at x equal to 1 for any value of lambda, or this function is continuous at x equal to 1, that is independent of lambda. This is. Thank you. So this is about the question number 18. Now I am requesting you kindly subscribe the Government Ghosh channel, that will help in study CBSE math. Thank you.